And so he got a settlement and he got back pay. Now he's back there working in the patent department. And so I have a friend in the patent department. But I could not, it would have been a conflict of interest for him to help me on my patent, so I had to exercise caution there. It's one of their tactics. My VMT patent was 3/4 of the way through, and suddenly I got a letter saying they disallowed all claims based on one word, and I don't have it memorized, but it was something to the effect that what I have here is the best thing I can find, the best way to do it. And it was obvious that I had studied all the other ones, but that one sentence didn't explicitly state that, and so they disallowed the whole thing. And I had to write a letter saying that, look, what do you think all these other references are for? And so they changed their position and allowed it. And another time, there's a lot of artwork in here. They disallowed it, saying all the artwork is too shoddy, too sloppy. And it was identical, except for 4 different figures. It was identical to the ones in the earlier patent, which they had already granted. And so they had a position that was ridiculous. I had to fight all that, and finally I got this second patent. I'm just telling you, it's when you're trying to break new ground, the establishment is against you. Now, I want to mention that I stand on the shoulders of a giant and a lesser giant. Alex Jones, about 1880 or thereabouts, got a device that moved like this, a single stroke one, a single cycle one, and you'd have to reset it, and he demonstrated this to Dr. Eric Lathwaite, and Dr. Eric Lathwaite was amazed by it. He was working on stuff like maglev, building speedy trains and things like that, and he was amazed by it, and he actually studied it, gave a guest lecture for the Royal Institute of London, and they thought he never said it, they thought he was trying to defy the laws of physics with some magic stunt or something, see, so that they blacklisted him, and they did not publish. That's the only one. Every year there's one. They didn't publish it, and that is so wrong, but it's an example of the establishment physicists, not only in the United States, but in Great Britain and wherever. And now, I used to correspond with Alex Jones. Then he passed away. Then I continued to correspond with his daughter. And his daughter told me that Eric Lathwaite stole Alex Jones's ideas. Alex Jones, I have a copy of his first patent. It was in German, and I translated it into English. I had German in my first year of college. Then he had a second patent, and he died before that was published. But his daughter gave me copies of his working papers on it, and so I have that. But Dr. Lathwaite basically stole his ideas according to Alex Jones's daughter, and Dr. Lathwaite knew what he was doing, and he's a very, very good engineer, electrical engineer, and he built a device that should work, but it was so complex that it would be impractical to build one. It could be built, but no big company in their right mind would try to manufacture it for production, because it's a Rube Goldberg type thing. Now you see this here, you might say it has only one moving part. And so you could say, how simple can it be? Well, that's true, and that's not true. Dr. Lathwaite wrote an article called Jabberwock, or something like that. And apparently that's something in Alice in Wonderland. It's a dragon or monster. If you touch it, it bites you. And he says, beware of the Jabberwock. And what he meant is that when you're playing with gyros, unexpected things will happen. And so if you try to change any parameter on this thing, it'll bite you. And so it was so hard. It reminds me of suppose you had a combination that had 10 numbers, this and that and that and that, 10 numbers. Now, I could show my son, who might be 10 years old, to learn to open that, and he could open in a minute. So I could tell any of you brilliant mathematicians and physicists, okay, take this and open it. You could spend a lifetime and not get it. Or you might be so smart that you would get it in a year or two or something, see? And I tell him, why does it take you that long? My son can do it in 1 minute. Well, the secret is someone already did it, and they know the answers to it. See, that's the same thing here. And I've gone through all the growing pains on that, and it's comparable to a combination that uses 10 different numbers. Okay, converting a downward force to a sideways force is supposed to be impossible, and I haven't done that. I convert downward force just to motion, which is not force. And so I've accomplished one thing. Now, another thing, rotary motion, they said you cannot convert it to unidirectional linear motion. Well, this does that also. That's two things. And now a third thing that I'll elaborate on is a little later, that nothing is supposed to be able to travel faster than the speed of light. Einstein's principle of relativity proves that. But, okay, it says, if you say nothing can travel faster than the speed of light, I am changing that to, I'm adding two words. The two words are be perceived. Nothing can be perceived to travel faster than the speed of light. And I will back that up with a simple statement like, if I could accelerate at, I'll say 2 G's, and all I need is a wristwatch that has batteries that'll last for 5 years, and a fish scale that goes up to 3 or 4 pounds, have a 1 pound mass. If I'm going to 1 G inside this spaceship, the scale should read 1 G. If I'm going to 2 G's, the weight should weigh 2 pounds. If I set it for 2 pounds and I go for 353 days, I'm at the speed of light. And to go to the nearest star, Alpha Centauri, which is 4.3 light years away, you'd have to get up actually to roughly twice the speed of sound after 2 days at 2 G's. Then you got to turn around and slow yourself down so you don't zip by it at 2 times the speed of light. And then you spend a year in orbit taking data on Alpha Centauri. Then you have to speed back up and then speed back down. And after 5 years, you're back home. Your wife is still there. Your kids are there. Maybe 2 of them graduated from college by now or something like that. So, and I'm saying that if someone tried to track, if they says, we're going to track Mr. Fiala out there, and that's fine when I'm going at 1/4 the speed of light, half the speed of light, and 3/4 speed of light. But what happens when I go faster than the speed of light? If they're using radar, I'm going like this, and the radar can't even catch me. So there's no way they can perceive my actual speed once I go past the speed of light, whether you use a laser beam or radar beam, whatever. And so that basically proves that that it should be altered to say nothing can be perceived to travel faster than the speed of light. Now, basically, I've converted downward motion to downward force to horizontal motion. I've converted uniform rotary motion to unidirectional linear motion. That's two things. And I built a good case for something can travel faster than the speed of light, but you can't measure it. That's three things. And so they're wrong on all things, and I'm saying that if they're wrong on all three things, and I've done two of them, and the third one I built a good case for it, then no one should claim that a device with inertial propulsion cannot produce a force. If you can produce a force, and I don't know how to do it, if you can produce a force, that'll accelerate something. Then if you have enough energy, like solar panels, you can have sustained acceleration. Once you have sustained acceleration, you can have travel to the stars then. Set your acceleration, I'll say, for 2 Gs, and go to Alpha Centauri. So now another thing, if someone was inspired by what I've done to be able to be more subtle than myself and develop a force, that would be great. Then they can have sustained acceleration. And then if they use zero-point energy, for example, and we know that that's going to happen because there's a dozen of these lectures here at this conference show that they tap into zero-point energy, but it's going to take someone more subtle to control it and power a rocket ship. But in 1 or 2 decades, they should have zero-point energy and hopefully a device that produces sustained acceleration. At that point, you could have travel to the stars, not just Alpha Centauri or, and so forth. So now let me see. Okay, we're gonna go through some slides now. Let's see. John, could you run the 12 slides right now, please? Okay, that's a picture of different pictures of this. I'm going to go through them fairly quickly, and at this point I'll actually dwell on them. But first I'll zip through them just to show you. Now I want to do it over once more. John, can you start that? John, start the slides over once more. Yeah. Now this is a very high precision. It's called a super high precision gyro. The rotor is balanced to 10 parts in a million, which is great, and it's suitable for these applications. But the rest of this device is very, very crude. This traction ring is such a high precision device, it's actually a hoop for crocheting. It's made out of pretty good plastic, and I had access to it. Actually, I went to a store and bought 7 of them. That was all they had. And this here is just a brass bar, and this is a 3/16 aluminum tubing, and these are simple wheels. They have a lot of friction. I could put bearings in them, but I'd have to machine out the holes, and so I built what I could. And it's looking at this, it's obvious that Mattel could build a toy, and a radio-controlled toy, and it could do it for $25 or do a high-class one for $50. And so after this is over, I plan to go to Boeing, NASA, DARPA, and Mattel. And maybe I'll start with Mattel, but I have to have a good video to show them, and so that they see that it's real. but you can see that, now this is a piecemeal, but there was a machinist, a friend of my son's. He has 3 CNC machines, and he was going to build me what I call a unibody one. This frame could be hollow and lighter than plastic, and there'd be a post in the middle. It'd all be unibody, what I call unibody, like some of the cars. And with only 2 weeks to go, he backed out. He wanted to be if he did that, he wanted to be a full partner. And by the way, these inventions have 3 inventors. There's myself, my son John, and his son John Arthur, because they've been with me all the way since 1995 on this project. And so he thought he could just, hey, if I want to take half a day and build you something, I want to be a full partner. And so I had to start from scratch, and I threw this together. So that's a kind of a history there. Whoops, did I hit the wrong one? There. This is just a different view of the same thing. Okay, you can see it's on a track that's calibrated. My memory is not that great. That's calibrated either in inches or kilometers or light years. I just forgot. I'd like to say also, actually you haven't seen it. Well, I'll say that a little bit later. These are just different views of it. There's an aspect of the gyro, and I had I'll back up. There's like a 1/4 inch wide or 1/2 inch wide traction wheel, and it rides on this. It rides on the rim. It rides on this rim, which is 3/16 of an inch wide, and unless it's so precise, now there's a little bit of flexing in here, and I used to have a 1/8 inch wide wheel here, and it could either slip inside or slip outside, so I had to resort to this. Here's a very, very expensive. I bought it off of a little toy car, and so okay, that's that, and okay, that's the end of those. Now I'd like to show the video, John, the video.
Part of why he's making the points that he's making is that you can also do this too. This is another technology that you can do at home. This is not, sometimes knowing the path through the forest is very hard to find. A lot of the settlers that took the Oregon Trail, 90% of them perished on the trail until they finally got the first path made. Once the first path is made, then the fatalities. Now, the freeway that follows that route, if they have more than 50 a year, there's a Senate investigation with the Department of Transportation. The people that are coming up with, while we're booting this video, that are pioneering all these different technologies, they're finding that path through the forest, but we're finding out that once you find that path, it's actually quite easy. And Harvey, the points that he's making here is that you can build this at home. You ready, Harvey?
Right. And anyone that builds it at home successfully, they owe me a dish of ice cream. Now, is this the first or the second video, John? This
is the second one, sir.
Is it? Okay. Now,
we can't run the other one.
It's designed for just one speed, and it doesn't have a motor, so it slows down. And this happens to be the first video, John, but that's okay. That's okay. But you can see it moves forward about 2 inches and backward about 1 inch, and that's because for half of the cycle it's in traction, the other half it's in precession. When it's in traction, it has full inertia, or you might say full mass. And some people erroneously say that at that point...
Sir, my mistake. That was the first video. This is the second one.
Okay, yeah. Here's the precession, traction, precession, traction, precession, traction. Now this thing actually isn't working very good, but when it gets down to the right speed, then it starts moving. You can see that. And Okay, okay, this half is traction, no, precession, that half is traction. This is traction, precession, traction, precession. And during traction, it has full inertia, also called full mass. During precession, it has only about half of its inertia. Some people would say half its mass, but you can see the mass is there, but a mass can have variable inertia depending on the acceleration that it's subjected to. So okay, let's see. Here's something, I just want to mention this. If you got going up toward the speed of light with inertial propulsion, in the speed of sound, as you approach the speed of sound, the noise of the aircraft is going ahead of you, but pretty soon when you approach the speed of sound, the noise accumulates in a big noise front, and you enter that. That's a sonic boom, and it can shatter your aircraft if you don't know what you're doing. You got to go through it rapidly, and you got to have enough rigidity to. Now, as you pass through the speed of light, and I don't believe that that's all relative, but if you were passing through the speed of light, and if there was an ether boom, and now this is humor, if you had headlights on your craft, and you were catching up to the light beam, and it was going to be super brilliant, which might burn you up, then right before you pass through the ether boom, turn your headlights off. Okay, but I don't think that'll be a problem. Okay, so let's see. Okay, here we go through the slide. That is the very simplest. Here it's in traction, and there, since it's in precession, it doesn't actually need anything there. The one reason there's something there is if it falls out of precession, it'll drop down and bust. So, but that's the simplest. It has one moving part and almost nothing to it. And so, yeah, I was told that all of you have a photographic memory and can read 10,000 words a minute. So some of these slides are going to zip through. That's a version, a different version. And here, this is a table of contents for the whole thing. Now here's where you can read 10,000 words a minute and just, okay. Here's an example of a vertical motion one that has to be tested out in the space station. And here is, this is the abstract for the, you see, whoops, I blew it. Can you get me back, John? I must have pushed the wrong button. Okay, the abstract. You can see it says, no wonder I had the wrong device. To move an object up and down, it should say, well, actually, I modified it. I put inertial propulsion device to move an object up and down. This is the abstract. And the abstract says that there's two devices. One uses gravity, and the other cannot use gravity. It depends on inertia, which is tied to the ether. And the establishment physicists and everyone now believe that the inertia of anything, see if I bump into something, I have to push it. It feels heavy. And its inertia, every atom in it is tied to every other atom in the universe instantaneously. It's called quantum entanglement. And so my body Every atom in my body is tied to every other atom in you and in the whole universe. And that gives us inertia. If I push you and you're on roller skates, you'll keep moving because you have inertia. And so I'm just saying that quantum entanglement, that's a new thing. And back in 1957, when I was in college, I wrote this article, Gravity, a New Means of Communication, question mark. Okay, and if it was instantaneous, I'm going to republish that article. It was about 14 pages, and I'm going to give it a subtitle called Quantum Entanglement, or Communication by Quantum Entanglement. About 10 years ago, I thought about getting a patent on a device to communicate to the planets instantaneously using quantum entanglement. But there's a lot of laboratories doing research. The Russians have established, they've quantumly entangled like over 180 kilometers, and now they're getting ready to do it between two satellites, which will be 1,000 miles apart. And so quantum entanglement is established. And so, and this, all the scientists used to say that gravity acts at the speed of light. And when I went to Hughes Aircraft, when I graduated from North Dakota State University, I had a Howard Hughes Master Science Fellowship to get a master's degree in EE at Caltech. And I worked for Hughes. Hughes is the one that offered it. So I spent 3.5 years at Hughes, and I started a program to measure the speed of gravitational interaction at Hughes. And I discussed this with Dr. Richard Feynman, and he pointed out to me that, well, he convinced me that it's at the speed of light and that it's impossible using any of my techniques to try to measure it. And by the way, I might mention, my wife used to come to me to these meetings with me, and 2 years ago she came in a wheelchair. Now she's at home with 24/7 nursing care, and she wishes she could be here, and I wish she could be here, but I forget what I was going to say. Well, at Hughes, after Dr. Feynman convinced me erroneously that you can't measure, well, that may be true, you can't measure it, but it is true that
We've got about 15 minutes.
Fine. Okay. It's true that it's instantaneous, and everyone accepts it, and don't try to measure it if it's instantaneous. You just got to sort of accept it. So I stopped that program after about a year at Hughes, which it is noteworthy that Hughes Aircraft would sponsor a program to measure the speed of gravitational interaction, even though my old professor told me I was crazy. Okay, this is more of the table of contents, so you can use your photographic memory in 2,000 words a minute to speed read it. The units, when you're working with inertial propulsion and there's no force involved, I had to invent new units, really, so that